We are going to tackle one of those scary word problems. This one's about simple interest. The word problem reads, a college student earned $5,100 during summer vacation. The student invested part of the money at 8% and the rest at 6%. If the student received a total of $380 in interest at the end of the year, how much was invested at 8%? The simple interest formula that we will need for this problem is I equals P times R times T. Interest equals principal times rate times time. I, or interest, stands for money. And this is the amount of money earned in interest. Like when you have a bank account and you leave your money sit there in your savings account and it earns that piddly amount, that's money in interest. Now, P, or principal, is also money, but this is a bigger pot of money generally. This is the money that you invested or that you were loaned in the problem. So this is generally the money that you start with, whereas interest is the money that you gain on the principal. R stands for interest rate, and for this one we're looking for a percent. But when you use percents, you always must convert them to decimals. And then T stands for time, and the time we are going to be looking for is the number of years in the problem. So again, we have the interest amount equal to the principal amount times the rate times the number of years. There's a lot of words in a word problem, and it can be pretty hard to navigate. So a really nice organizational tool is to make a chart. When you set up your chart, you need the answer to the formula to be on the right-hand side. So we need to move this I over to this side of the equation. So we'll write instead principal times rate times time equals interest. And when you make your chart, you want a column for each one of the letters in the formula. And we will want 3 rows. This is because you typically have 2 scenarios in your problem. So the first row is for whatever is happening in our first situation. In our case, we're investing money in 2 different accounts. So this will refer to the first account we invest, and this second row will be the second account. The third row typically stands for the total of the 2 accounts. Let's read the problem again, and every time we hit a number, see if you can fill it in the chart in the correct spot, whether it's a principal, a rate, a time, or interest, and if it refers to the first scenario, the second, or total. A college student earned $5,100 during summer vacation. The student invested part of the money at 8% and the rest at 6%. If the student received a total of $380 in interest at the end of the year, how much was invested at 8%? Okay, the first amount was $5,100. That was the total amount the college student earned during summer vacation. That is our principal, and it's our total principal. So it goes right here. The student invested part of the money at 8% and the rest at 6%. Those are both interest rates, so they go in the R column under 1 and 2. But remember, you have to convert to a decimal, so we're going to write, instead of 8%, 0.08, and instead of 6%, 0.06. The student received a total, that's the total row, of $380 in interest. That's our I total, 380. And then it says, at the end of the year. That didn't seem like a number, but that tells us our time frame. That means it's been 1 year. So altogether, it's been 1 year. But since both of these accounts are probably being invested at the same time, it's actually 1 year for each of the investments as well. So that's all of the numbers filled in. The chart is to fill in the last column, because this is what's going to generate our equation that we will solve. So you must go back and fill in any boxes necessary in order to complete the last column. You're going to be working across from left to right using the formula principal times rate times time equals interest, which means if you look at the bottom row, we already have the 380 in the last column, so we do not need this spot to fill in order to accomplish our last column value. We do, however, need the two principal amounts, but we don't have either one. We only have the total. And the question at the end of the problem asked, how much was invested at 8%? That means the thing we are looking for in the problem is the amount that needs to be invested at 8%. So that is our variable for this problem, x. Now, we also don't know how much is invested at the 6%, but we're not going to use another variable because we need to keep this all in terms of one variable so we can solve it. If the total is $5,100 and part is invested at 8%, that's the x, then the rest is invested at the 6%, the rest of the $5,100. So if you take the $5,100 and you subtract away however much x is, that will be whatever's left over to be invested in the second account. Now work across from left to right to fill in the last column. For the first row, x times 0.08 times 1 is 0.08x. For the second row, 5,100 minus x times 0.06 times 1 is 0.06 times the quantity 5,100 minus x. Great, now you have the whole chart filled in and you're ready to write your equation and solve. The equation is found by looking at the last column, the I column. The interest amount for the first account, or the first interest amount, plus the interest amount from the second account should add up to a total interest amount. So the interest amount for row 1 was 0.08x. The interest amount for row 2 was 0.06 times 5,100 minus x. And that is equal to our total interest of $380. Now all we have left to do is solve this equation. You may remember a technique called clearing the decimals, which allows us to multiply the entire equation by 100 in order to adjust these decimal values to become whole values. That will make this 8x plus 6 times 5,100 minus x. But remember, you have to do it to the other side too. So this becomes, instead of 380, you will tack on 2 more zeros and make it 38,000. I know these are big numbers, so you'll want to work over on the margins while we go through the problem. Starting with the 6 times 5,100, we will need to take that over here and work it out. So this is 0, 0, 6 times 1 is 6, and 30. So we've got 8x plus 30,600 minus 6x. Don't forget to distribute that 6. Equals 38,000. The 8x minus 6x gives us 2x plus the 30,600. Subtracting this over gives us 2x equals $7,400. And lastly, we'll need to divide by 2. So we will take 7,400 divided by 2. 2 into 7 goes 3 times. And 2 into 14 goes 7 times, evenly, and there's 2 more zeros. So x equals 3,700. If you look back at the chart, you'll see that x was the amount invested at 8%, which is exactly what the question asked us. How much was invested at 8%? And this right here is our answer. So we will put $3,700.